Good morning, good morning. Everybody hear me? Check, baby, 1, 2, 3. No reference? No? Okay. Good morning, everybody. My name's Tim Hewer. I'm one of the program managers on the Windows XAML team. Thanks for coming this morning. I appreciate everyone coming from the attendee party, and hope you had a good time. Hope you're enjoying the week. How many people have been going to all the XAML sessions? Good amount. I see some familiar faces. So by now, hopefully, you've been, it was a long day one, keynote, plus all the big picture sessions and stuff, but very valuable in us understanding what Windows Metro is all about, what Windows 8 is bringing to us for the developers. And so the past couple days of being able to talk and hear from my team, and Joe giving the overview of kind of what's new for you if you're a XAML developer, Hamid talking about some of the new controls, et cetera, and Alner just finished up on some of the great things that we're doing with touch in the XAML platform. So hopefully, you're getting a good broad picture of what we're doing for Windows XAML. If it hasn't been said enough, we value your feedback, so come find us and send us that feedback. So I'm grateful to have an opportunity to talk to you today. Just a little bit about myself. So I've been with Microsoft for 7 years. Prior to that, I was in the industry as one of your comrades, in about 10 years doing software development for consultings, rode the .com wave, had awesome VC money, and buying cookies in our offices and stuff like that. And of course, everything implodes and your world ends. But yeah, had an opportunity to join Microsoft, and I first joined in the evangelism team, working with ASP.NET and SharePoint and a lot of web technologies. And then when Silverlight 1 came around, had an opportunity to work for Scott Guthrie and start doing a lot of the community outreach. And so that's how I got involved in XAML. I went from a web technology to a client technology. So over the past 4 years, I've had a really great opportunity to work in the XAML world, both from a community standpoint and then more recently over the past 2 years on the engineering team. And I've really enjoyed my time working with the XAML technologies and Silverlight and WPF, and now Windows XAML. So I'm grateful to be here, and thank you for coming as well. So this session is the marketing-driven title, of course, reaching all your customers' devices with one beautiful XAML interface. I thought about putting up a slide with all the fast, fluid, reimagining, all the buzzwords, just get them out of the way. But basically, this session is talking about how you can manage the different layouts and the things that you've seen about the Windows 8 personalities and the Metro-style applications, and how you as a developer need to adapt and can tailor your applications specifically to those different views. So I will show some sample applications, but I am also going to try to keep it at a fundamental level and try to just talk about the core concepts and not try to use a ton of the sample applications to detract from the core message that I'm going to try to deliver here. So from an agenda standpoint, I like to use the term adaptability. So we're going to talk about, how do you need to adapt your application to the different layout views that were introduced for Metro-style applications, screen sizes, and these different things. What are the XAML-specific patterns that you, as a XAML developer, can adopt and have available to you for easy methods, as well as, like I said, tailoring your specific methods. And that's kind of that third point of providing unique views in the snap state. And I'll define all these in a little bit. So I hope you leave with the ability to understand why it's important to adapt your user interface for your Metro-style application, and some techniques that we're proposing to help you do that easily. So let's just set the stage, and I just want to, because I'm going to be using different words and terms and stuff, I just kind of wanted to level set and make sure that we're all on the same page as far as what the different terms that we'll use are here. So I have just the out-of-the-box template, the grid application, and I'm just going to run it here. And again, like I said, I'm going to try to focus on just the fundamentals and walk through some of these things here. So this is a grid layout. If you were in Hamid's session, this is a grouped grid view control, and you can see that we have several different groups. I can choose a specific collection and drill down into more detail, get us another specific item, navigate through different items in the collection, and navigate through a backstack as well. So a pretty standard kind of metro-style flow of consuming information. Now, what you're seeing here is this is the full screen experience, right? So you've heard terms like immersive and the application completely owning the screen. There's no Chrome from Windows, from the OS, or other applications that are involved in yours. So you own every pixel on the screen, and you have the ability and should take advantage of that screen real estate. Now, the other thing is that we have these different types of views here. So, whoops. We have this one view here that's called a snapped view or a snapped app. And if you have a touch device, so my particular laptop is not a touch device. You gesture in from the left edge and pull an app in, and you can snap an app that way. You saw that I was able to do it from the keyboard, so if you haven't found that keyboard shortcut yet, it's the Windows key plus period. Will allow you to toggle snap state across the OS. There's actually a number of Win key shortcuts, so I don't know if they're publishing those, but they're extremely helpful on a non-touch device. So this is what we call the snap view, and you can see that my particular application has adapted to this view, but has provided what we call a continuous experience, right? So I was seeing collection information, collection 1, collection 2. I've snapped the application, and I'm still seeing that continuous flow of information. If I go back to the full view and actually select an item and snap that particular item, you can see that from a contextual standpoint, I'm still in that particular flow, right? I was viewing this particular, I don't speak Latin, so I won't try to pronounce it, but this particular item, and when I snap the application, I'm still viewing that item. I've just provided a different view in that snap state. Now, what the left side, or the center area here, and let me just snap Visual Studio, which actually does not work well in a snap view, of course, right? So it's a classic desktop application, and when you snap a desktop application, you get this view of kind of the Alt-Tab view, basically. But now what you can see is that my application no longer owns the full screen experience. I'm participated in what we call the filled state. So far we've seen 3 states, and we'll review them as well. We've got the full screen state, the snapped state, and the filled state. So right now my collection application, my grid application, is in that filled state. And this is important to understand of how much pixels you have available to you. So those are the different kind of layout states. Let me go back to Visual Studio, stop the debugger. And we also have this concept of orientation, right? You guys, some of you have been able to receive those tablet devices. Hopefully you've been able to play around with them. I've been sitting in the back of sessions in different rooms, and I see just glowing blue lights all over the place, so I know people are using them. And those have really good specs on them, so they have the full capabilities of all these sensors, including the ability to rotate. Now, I'm on a laptop. I don't have the ability to anybody have a rotate laptop? I've never seen one, but so I'm not able to actually rotate my device, but in Visual Studio, we've created a simulator experience that allows you to be able to test your applications in this second part of kind of view management, which is orientation view, right? So we've got this layout view and an orientation view are these themes that I hope to get across to you today. So this is the simulator, and there's other things that are available to you on here, one of which we'll cover as well, but I'm not going to cover the touch emulation. But these two things allow us to rotate the simulator. So I'm just going to rotate it, and you'll see that I have that grid application. And now we've rotated my application or rotated the simulator, and now we're in portrait view. So this is yet another view that you as an application developer have to be aware about, or can be aware about. And you can see, again, this is a continuous experience. I have the grid application. I'm just laying out the information slightly differently. And so if I go back to the landscape view, same information, just laid out differently. And in fact, in the portrait view here, it's the exact same grid view. So that's kind of trying to set the stage here of the taxonomy that I'll use and the fundamentals that I wanted to cover here. The key is that I don't have those awesome table of devices behind me, but in the keynote you saw Mike Angelo talk about all the different devices that Windows runs on, from the smallest of devices and the thinnest of devices, and the smallest of pixels to the largest of screens, perhaps even projectors and those type of things. So the key is that the Windows promise is that the user is in control. So Windows is allowing and has always allowed, right? This is not a new thought here, is that Windows allows you as the user to be in control of the screens you use, the devices you use, and where do you choose to run Windows. So that's an important message to really understand, because we as developers have to adapt to that. We don't have a single specification that we can target and laser focus our layout on. So we need to adapt to what users are going to choose to be most productive in. So there's 3 areas that I wanted to talk about in this session. And the first one is screen sizes. The second one we'll talk about orientation. And the third is pixel density. So screen sizes, we just walked through the grid application, and I'll be referring back to that walkthrough and as we do some samples here. We talked about the snapped and the filled state. Now the filled state, you saw that we no longer own the full screen, but we do have the ability of some part of the screen. And this was touched about in the keynote and as well as in Jensen's talk. And this is the reason why a Metro-style application is required to, you must have a minimum 1024 by 768 resolution to run a Metro-style application. And it just turns out that on the baseline resolution, which is 1366 768, that's the resolution of the tablet that you have as well, and my laptop as well here. This is a Lenovo X220, that's the default resolution there. It just so happens that the filled state is 1024 by 768. So if you kind of do the math here, you can obviously see that we take our baseline resolution and we're affording for a snapped application plus that gutter that you saw that I'll talk about in a second. And that is the requirement of why your application must be designed kind of for a minimum 1024 by 768. Now, your app should maintain some consistency in how you run your application across the different screen sizes. And you need to be aware that you can run at these different resolutions, and so you should adapt to them and provide a very consistent experience. And then also, understand that you can have more real estate, right? So somebody may not be running your application on a tablet. They may be running it on their 52-inch TV that's connected through HDMI or something like that. So you have to understand that you can take advantage of this added screen real estate. Now, there's a couple ways. I should have actually named this fast and fluid layout, I guess. So there's a couple ways that XAML can help you here. And actually, these are not net new things in XAML. This is something that fundamentally XAML has always been designed for from the beginning, is this concept of a fluid or a flow layout is probably a more appropriate term. 2 things that will help you take advantage of this extra screen real estate. Horizontal and vertical stretch modes, or stretch modes in general on content alignment and horizontal and vertical alignment, as well as what we call star sizing. And let me show you some examples here. And again, this is not a new concept. I think there's a lot of XAML developers in the audience, so this should be very familiar. For those who aren't, this is a good tip. So this is an example of a fixed layout in XAML. This is a simple grid, and again, I'm just focusing on some fundamentals, so you're going to see a lot of rectangles here. But this is a simple grid with 3 columns. And if we were to render this application on, let's say, the baseline resolution 1366 by 768, you'd see that let's assume the red rectangle is my content area. That's where I really want my user to focus, right? So I'm wasting a lot of screen real estate in the space here. And what's causing the issue here is this column definition. This is a very fixed layout. I, as the developer here, have not afforded for extra screen real estate. I've just designed towards one thing in my application, and I'm kind of really screwing the user at this point from having a real usable application. So in contrast with that, we have this concept of star sizing in XAML. And so this is the same XAML. And if we were to run this app, we'll modify XAML a little bit. We were to run this XAML, we could see that now that content area of where I want the user to focus is filling a certain available content area on the screen. And that's because we've added a simple addition to the grid column. We've just added a star. So essentially, you could read this as star sizing is kind of a min-width, min-height concept. And so now you can read this as the second column is defined as you must be a minimum 250, but take up the rest of the available space on the screen that the user has. And again, this is not new to XAML. This is not new to Windows XAML. This is actually fundamentally what we've always designed for. The second one is this concept of stretch modes. And I don't have a visual for this, but you could apply this to UI elements that are in XAML. And so if you wanted a UI element to fill the available space that it's contained within, in this case, that second column, this button, exactly how you see the XAML rendering here, would have a width, the entire length of that middle column there. So probably something you don't want to do with a button, but an obscene example to demonstrate the purpose. So those are two things that you can do in XAML that have always been available that you should be designing for to get that kind of that free flow layout in XAML here. Now, when we walked through the grid application, we talked a lot about we saw the snap state and the shortcut, the Windows dot or Windows period. And so there's a couple things that you need to understand about the snapped applications that hopefully you've seen as you've experienced, and that you'll take away from this to really, as a developer, make sure you tailor that experience. So snapped applications are always 320 pixels wide. This is one area that, regardless of the screen resolution, that you can count on from a design perspective. That if you're designing for the snapped app, regardless of 1366 by 768 or 8 billion by 4 billion, the snapped app is going to be this specific area. The other thing that you need to know is that the user is in control of the snap application, and that snapped applications are always available. This is not a feature that you as a developer can set a setting and turn off and say, I don't want to have a snapped application, or prevent the user from snapping. There's no event that you will get that you can intercept and say, oh, the user's trying to snap, don't let them go to full screen or do something else. You will just get an event that will show that you have been notified that you have been snapped. So those are two fundamental things that you really must understand, is that the user's in control and every app can snap. And so if you don't remember that, you're probably not developing a good experience for your customers. Now, I talked about continuous. So the ideal thing that you want to do as a developer is provide a continuous flow of your application. So I'm doing something contextually. I've snapped my application because I want to do some multitasking. But that snapped app should ideally, if at all possible, have that contextual continuous experience, right? I'm watching a full screen movie. I've snapped an application because I saw an incoming mail or something like that. I want to address it. But I should still have that movie in the snapped app. Maybe it's not playing anymore. Maybe it's paused, and maybe I'm showing a playlist or something like that. But it's still contextual. I'm in a chat application that's full screen. I snap the application. Now I still see, maybe just a smaller view of my chats. Maybe not all of the chats I was in, maybe just one specific, but still, again, contextual. Now that is not a requirement of the design principle. That's I guess a strong suggestion that you should provide this continuous and contextual experience. However, you do have the capability of defining a very specific tailored experience. So if there is something that you can do to tailor in that 320 width area, you do have that capability of doing that. Certain games probably don't make sense that are going to be able to be played in 320 pixels, right? So like Doom or something, I don't know, some first-person shooter or some other type of things that there are absolute scenarios where you want to tailor that specific experience, and we provide ways to do that. One of the ways that we provide is, and that I'll demonstrate, is using the XAML navigation framework to easily kind of navigate to different literal views of your application and be able to pass state back and forth, whether that state is very simple string-based information or full objects that you want to hydrate back and forth. And then the last point there is that understanding that scrolling patterns and kind of touch patterns in snap state are very different. And just to demonstrate that, so again, let's bring up this screen here and talking about these are the areas that we're talking about here. On the left side, this is the baseline resolution, so 1366, and you may be doing your math and saying, those don't add up. So you get 22 pixels for the gutter, that area that the user can touch. And so on the left side is the 320 pixel snapped area. On the right is the filled area. So let's take a look back at our grid application. This is the grid application. This is in full screen. Now when I snap the application, I'm back in this snap view. I now have 320 pixels. Again, we've designed to have a continuous experience here. And this is one of the templates you can explore that are out of the box in Visual Studio. Now, one also thing to note that you actually saw it when I first launched this is that a lot of the demos that you're probably seeing is showing snapped on the left side. And in fact, the screenshot that I just showed snapped on the left side. Again, the user is in complete control. Don't design your snap view assuming that will always be a left side snap. So a right side snap is entirely possible, and the user can shift between one or the other. So if you're doing something that's doing arrow pointing, assuming that things are going to be on the left side or the right side, that's a bad design principle. Again, the user's in control of where your app is going to be. Now, I talked about scrolling patterns as well. So in the grid application, in the full screen, you saw that when we were panning and scrolling with the mouse, that it was a left-right motion. Now you notice that in the snap view, things are aligned vertically. So the scrolling pattern in the snap view should be a vertical up and down motion. And the reason for that is, let's say we have our snapped application and we scroll horizontally, or we have something that allows to scroll horizontally. And you can see in this illustration what just happened. Right? The user's touch point crossed the snap line. And instead of the user's intent wanting to pan content within the snap view, I very likely could have just unsnapped the application. And that was not my user intent, right? So that's, at this point, that's a colossal fail, right? So don't do that. So just understand the different scrolling patterns in Snapped here. So the second point that we're going to demonstrate is talking about orientation. Now, orientation is available for devices that can be rotated. So you'll have to have, some type of gyroscope sensor or something like that can be rotated. Or if the user has preference, right, and you can set your screen settings to have a landscape or portrait view itself. So on your tablet devices, it will automatically do it, or on my, I don't know why I would do it on my laptop, but in a dual mon situation, I could have one monitor that's landscape and one that's portrait. Windows supports devices, and a monitor is a device that can be rotated. Your app, same principles apply to snapped applications. Your app should behave consistently in the orientation changes, and your app can be tailored to those specific orientations. Two key points about orientation, more specifically to portrait. We talked about like the filled and the snap state. Those don't apply in portrait mode. So portrait is always a full screen application. There is no multitasking in portrait mode. I can't snap another application. If I had a snapped application and a filled application and I rotate to portrait, that filled application now gets priority and consumes the screen. The other thing is that your application can prefer and or lock an orientation if you see fit. Usually this applies to gaming samples as well, where you have a very, very immersive game that you want to use that full landscape area, and you don't feel it's appropriate to have a portrait view because it's too narrow or something like that. So you as an app developer can prefer an orientation. What I mean by, so that's an example of locking an orientation. By preferring an orientation, what I mean is that you, in your manifest, and I think I have a code snippet of this. So here's an example of our grid application that we showed in landscape and portrait. So here we're talking about preferred orientation. This is a snippet from the application manifest. Has anyone built an application so far since you got the bits? A couple people, so explored. So this is a snippet from in Visual Studio. The file at source view is called package.appxmanifest. This is a snippet from the application node of that. There is a visual representation of this in the Visual Studio has a manifest designer, but I just wanted to call out the actual value that gets set in the manifest. So in the manifest, you can set this value, initial rotation preference. And there's 4 values. Technically, there's 5. If I don't have this value, I'm not preferring any rotation preference, right? So currently, there is no none in the enumeration, but you could assume omission of this attribute is none. But there's 4. There's landscape and flipped, portrait and flipped. And I won't show it on the screen, but I'll try to do my best here. Is if I'm holding the tablet like this, and I start an application, if I was to go to the start screen and start an application, that had an initial rotation preference of portrait, what you would see is the splash screen tilted. Right? So by setting this property, I'm basically saying, when my application launch in this mode first, and then react. Right? So if it was portrait, it would launch in portrait, and hopefully it would adapt to layout changes and quickly switch to landscape. Same thing as if I was holding it in landscape, and this property, as you see it on the screen, was launched, you would see something horizontally. So just understand what these properties are. And this is a preference. This is basically, this value right here is just a launch preference. This is not the lock that I talked about. The second part, and this is an example in C#, everything that I'm going to show in code is completely available in C++ as well. And I'm just more productive in C#, so as I go through the demos, that's what I'll be showing. But this is across the board, C#, VB, and C++. Everything applies here. So this is an example of actually locking the rotation. So now that I do have to do this in code. I probably should do this as well in combination with that manifest suggestion where I say, hey, I'm preferring this rotation, and I'm also in code now when my app is activated. So I'm doing this in the default launched activation. That now I'm setting my rotation preferences are landscape and flip. And the flipped is basically, think about it as wherever the home button is. So this is landscape flipped. Right? So by setting landscape and landscape flipped, I'm supporting whether the user is holding it this way or technically upside down. And portrait flipped are the same type of things. So by putting this code in here, I've locked the orientation. And again, that's completely acceptable. You should know why you're doing that. You probably shouldn't do it just because you don't have time and you just need to release software. Like, that's probably a bad experience. But if you're doing something that you really want that full landscape, I anticipate people will lock landscape more so than portrait. But you could do both. This is just an example of locking landscape. Now, so in XAML, how do you adapt to all these? And I promise we're getting to some code, so I promise we'll get there. In XAML, we have always had the capability on UI elements that they are aware of their size. And as size changes, they can be notified of their size. And you as a developer can attach to measure events and resize events across the board on any framework element. And you will always be able to get them. That still applies. So if you have a grid and you want to know when that grid resizes, you can still do that. You can still listen for that event, and you can still capture those measures and react to them as you need. However, the point that I want to make here is that for the things that I just talked about as far as orientation and layout changes, you really shouldn't count on the resize events in XAML or the measure events in XAML. Again, those will still fire. You will still get those. But we have provided, and WinRT is providing you a way to explicitly know that orientation has changed and layouts have changed. Like, your app is now in snap view and your app is now in filled view. So we're saving you some time from having to do a little math and calculate these size changes. So resize events will still happen. You will absolutely still get them. They should be treated different than the layout and the orientation events. Question? No? Good. Okay. And then the layout events, as we saw, that you will get the different view state changes, full screen, filled, and snap. And the orientation is basically portrait to landscape, landscape to portrait. So this is not PowerPoint crashing. This is, again, just to kind of show that this would be your full screen view. And again, we have the snapped and the filled view. Now, these are the actual names of the layout properties that you will get through the APIs. Full screen, filled, and snap. So one of the things that we're interested in getting feedback on, I guess is a good way of putting it, is using Visual State Manager as a pattern for easily enabling you to do this layout management. And Hamid, if you went to Hamid's session, John Papa's session on styling, he talked about what Visual State Manager is. It's a mechanism that's existed, again, in XAML for a while that allows you to define specific states on specific elements in your visual tree. Most people do it on the root page, but you can do it on a granular level as well. And so by using visual states for each of the layout states, and so here again we have the full screen, filled, snapped, and portrait, we can use the built-in method in Visual State Manager, which is the go-to-state API, to say, hey, I've been notified I've been rotated, go to state portrait. And I've defined what portrait means to me as a developer. I don't have to write a ton of code. I can do this declaratively or in my view or view model, listen to it in my view model and have it just defined in my view here. So I've talked a lot. Let's take a look at some of this. Let me log in real quick. You got to know your password. That would be bad. Okay, so we talked about that. Let's close that one. Close the simulator. And let's look at, so I've just created a blank application. And just by way of showing you where that initial rotation preference is, here's the manifest designer here. And at the bottom of that initial rotation preference. So that sets that property that we were talking about there for a preference, not a lock. So I've got this application here, created just a blank application. And let's load it up with just some basic XAML. And so here I just have a stack panel that has a border and just this is a hello world here. And I have some properties on the border. The border is blue. The text is a 72-point font. And just to show the different areas here, what we're going to do is just introduce to you the APIs of how you do this and how VSM could help easily do this. And this is, this is a very simple example, but I'll show you one of the sample applications that's on your tablet and how we did it as well there. But just to set the stage here. So on this grid, I can now define some view states, and we'll just set them up. And so how you use VSM is you define a visual state group, or a visual state group, and then you can define your set of visual states in here. The canonical example is a button, right? A button has a normal state, it has a hover state, it has a press state, and I think that's it for our buttons. So those are kind of the canonical examples that are built in. So VSM is actually built into a lot of the framework controls. And then so here's an example. I'm just defining a visual state group called orientation states. Now notice I'm just using the literal names that I know that the API is going to provide for me. And that's going to give me an easy way to translate those things. So I've defined these visual states. I can run this application, and it's going to do absolutely nothing, right? Because we haven't changed anything as far as what we've said the visual states to do. So this is our base. If I was to snap this application now, I would get that. You can see text is cropping. It's not a good experience for the user. Arguably, the application itself is not a good experience, but let's leave that aside. Okay, so now what I want to do is actually listen for those layout changes. So in here, I'm just going to go into the code here, and when this is initialized, I'm going to go to, application layout, bring up the namespace, and I'm basically getting this API, I'm getting the application layout manager for the current view. Right? So in this case, it's just my main page. So I'm telling the API, hey, application layout, give me your instance, and I want to listen for your layout changed event. And by doing that, I can now attach an event handler for layout changed, and I get who the sender was, which is the view manager, as well as what the changed event arguments are going to be. So I can start looking in here and spelunking, hey, if your layout, this is an enumeration, application layout state, you can see, hey, these are convenient, filled, full screen, snapped, right? That maps directly to my VSM states. So I can say if you're filled, do this, et cetera, and do some if then else type things. But that's really not going to help me a ton as far as understanding, if I was snapped, now I'm going to portrait and different things like that. So what we can do is have just a quick helper method that resolve some namespaces. Key. That allows me to use a couple other APIs that we'll see that apply to rotation as well. So I'm using this static method just as a helper method to say, hey, I want to be able to get to view state. And the first thing I want to check is the orientation, because I, as a developer, know that if I'm portrait, none of the other states apply to me, right? I'm full screen in portrait. I don't have to worry about snap. I know that I'm going to own that screen. So I first want to get the current orientation. And so I want to know if the orientation is portrait or portrait and flipped, right? So those are the two things. Those are still portrait to me. Then immediately I'm just going to return, hey, portrait. I don't even need to inspect whether the layout is filled or snapped or anything, because it will always be full screen. Portrait will always return application layout full screen. If it's not portrait, then I'm just going to say, give me whatever the value is. So it's important to note that this layout changed, as its name, layout changed. It's not layout changing. I can't intercept it. It has happened. I'm just responding to it at this point. So once I get that layout changed event, if my orientation is portrait, tell me I'm portrait. Otherwise, just return the string of application layout value, which will be one of the application layout state enumeration that you saw. So now by doing this, I can go into my my layout changed event handler, and I can say go to state this. Get view state. And I don't want to use animations. So by using this one line of code, I can now say go to state, and my helper method is going to help me determine what the state is. And it's going to return one of the values that just happened to match my name. Now, it's important, if you're not familiar with VSM, I could have named any of my states anything I want. What we're just trying to introduce here is that just as a best practice, you should name, if you're using this method, you should name them matching the actual state of the screen here. So if we were to run this application here, again, it would not do much, and that's because we're not defining anything, right? So I can snap an application here, and nothing's changed. If I make this the snapped application, you can see that we still have a bad experience there. And that's because we really haven't defined anything within these states at all. So let's go ahead and do that. So I'm going to define just a filled and a snapped state. And I am copy and pasting just so I don't make mistakes here. And so what I'm doing, if you're not familiar with VSM, is I'm creating a storyboard. I'm telling it the final state of that visual state that I want to happen. In this case, the filled screen, I want to change a couple things. I want to change that border. So I'm telling it, hey, the item border, I want you to change the background to red, and the text, change the font size to 48 size. And then in snapped, again, I'm just changing those two things just so we can illustrate the purpose. I'm changing the border to green and a smaller font size, so that I think that will give my application a better and continuous experience here. So there's our full screen state. If I snap the application, there's our filled state, or snap another application, sorry. If I snap my application, and there's our snap state. And so Visual State Manager, and using the go to state APIs and defining them as matching alongside the application layout, just gave me a really quick and easy way to create a continuous experience for my application. Now, portrait is a different experience here. So again, portrait is different than the actual layout views. And display properties. So we have an orientation changed event. And I would really actually just do the same thing, right? I just need to know that orientation changed, or layout has changed. And so an orientation change, I can actually call the same method. And then I would just have to define a portrait method here. And so in here, I actually don't have an element, so let me remember what I named it. Maybe my experience is still continuous, but it has different particular elements here. So let's do, I'll just do something here. Font size. We'll do And so what I'm setting here is I have this text block that is not visible in any of the other views, but in Portrait, I'm telling it two things. I'm saying, hey, when you're in portrait mode, collapse the other panel and show this other element. And now, because I don't have a rotatable device, I can use the simulator here and start the simulator. A tip on the simulator, if you're a Windows Phone developer, the same tip applies. Like once you start the simulator once, keep it up. It will save you the startup time. And there actually is a warning when you close the simulator stating to that effect. So here I have my landscape application. When I rotate the application, we can see that we've used Visual State Manager to provide the portrait view again. So listening to a different event, but using the same method of VSM to apply there. So that's using layout with Visual State Manager, and that's an easy way for you to provide a continuous experience across your application. The other method you may want to do is using navigation framework. And the navigation framework exists in Windows XAML. It's made up of if you're familiar with the Silverlight model of frame and pages, the same concepts apply there as well. So let's go ahead and just create a very simple illustration of this using the navigation framework. So I'm going to create our application here, my application. And then here, I'm going to create a frame. And that's going to hold, frame elements hold things that Marco demonstrated, hold things that can be navigated, right? So this will always exist, this title. And then this is the content. Anything within this frame is the area that can be navigated to here. And let me go in here. So I have a couple other user controls here. Actually, they're page elements. I have my initial page. You can see that they derive from page. And we'll just put some text in here just to show the concepts. And then I have snap view. So my goal in this application, I as an app developer have decided I want a uniquely distinct view in snap state, but I don't want it to bloat my current visual tree. Right? So I want to be able to navigate to that snap state. I don't want it to be in my visual tree or navigate to using Visual State Manager at all. So and this is also, the snap view is also a page element. And we'll just call it, this is snapped. And so I have those two pages. And so in my initial view here, we will just say main nav. We're going to navigate to the type of initial page. And then, so in our, that's our main page. So we're setting the initial content to this user control, or this view, if you're using a view model approach. And in our main page, we're basically setting the initial one there, but we also need to listen to whether or not we've been snapped or not, right? So I can go in here and I'll use the same application layout, get for current view, layout changed, use my helper method. Actually, I don't need the helper method here. So what I want to do in the layout changed is I want to say if the layout has changed to snapped, then I want to tell my frame navigate to, what I call it, snap view, and show that information. Now, let's say I have information that I want to pass. I want some state, right? So I am actually navigating to a different user control, but I do want to probably provide some continuous data or exchange there. So I can pass an object here. You can see the signature of navigate to allows me to pass an object here. I'll just pass a string. And in my snap view, I can listen to when I was navigated to, so I can override the on navigated to. And set that to the arg that I got, which is the parameter. So what we've set up here is on the main page, we've set up our UI. This is going to be our full screen application. But I've really set up my content area to be this frame. And I'm initially navigating to what I want for the full screen. But when that particular page gets changed to snap view, I'm saying, hey, go to the snap view and pass this state information. In this case, we're just passing a simple string. And in the snap view, I'm listening to when I've received information. I'll accept that parameter, and I'll act upon that. And so if we did everything correctly. And this is a method you see that there's no VSM and there's no defined states within this particular view here. So I have my initial page application. I'll snap the desktop. And you can see that we haven't defined anything for filled or anything like that. But as we snap the application, we've navigated the header. Again, we're using that frame page concept. So the header, I could provide some consistency of the header. Or in fact, on the main page itself, I could have still used VSM as well to maybe change the font size of the header, very simple properties. But the actual content, I want to be something different. And I can see that I've changed, and I've accepted and passed that state information along. So 2 concepts to help you do the layout changes there. Both using VSM as well as being able to use the navigation framework. And I forgot that we did want to show a more complete application. So one of the sample applications is Sudoku. Myself and one of my teammates wrote. And we use these methods. So you can see here's our orientation helper. In the page itself, we're defining our orientation states, full screen, filled, and portrait. And so if we were to run this application here, here's our full screen view. And this game has particularly been paused here. So I'll snap the, this will be very subtle. So if you pay attention to some of the margins here, we know that we're going to have the full available screen real estate. But when an application is going to be snapped, we know that we won't have the full state available to us. We will be 1024. So we move in the margins a little bit. And we do that by we are using some star sizing on those left and right number pad areas. But we're providing a very still consistent, just making sure that we're kind of margin aware at this point. Now, our team particularly decided that the game board here is, if you've ever played Sudoku, the numbers are the most important thing, and you got to be able to see them. And so we decided that this 320 pixel space was not ideal for playing this game, and the touch points probably would be smaller than desired for us. So when we go to snap view, what we do is we actually pause the game on behalf of the user. And so we're using the if you've been to any of the sessions, and Joe and Marco mentioned this in their sessions, the process lifetime management, where an app becomes suspended and those techniques that you have to do, we're effectively using the same technique here. In fact, we're using the same API. So if the app is suspended, the same method gets called. But we're saying, hey, if we're in snapped, that's not a desired user experience for this particular game, so show a completely different view. And so we just inform the user that, hey, the Sudoku app is over here, your game is paused. Because we think, if you're our approach was that if you're playing a game and you've decided to multitask, since the game is timer-based and that's how you're scored, you're probably wanting it to pause it. But we don't show you the game board, right? So you can't cheat. So we talked about the portrait aspect. So let me show you what we did in portrait. So for this, I'll start the simulator. And this is a complete VSM approach. This isn't using, so even on the pause game, because we were okay not displaying any other information, we just paused the game and collapsed and showed 2 different regions here. So here's our Sudoku as the landscape view. And let me go ahead and start a new game. And I've got this view here. And notice the number pads are on the left and right. And so now if I rotate portrait, what we've done is we've just moved things around. And so it was very subtle, and the remote desktop nature of the simulator doesn't show it. But one of the other methods we used was where Hamid and John talked about the theme, transitions, and animations. So we did that because we're repositioning things. So we have on our number pad and on our game board, we simply put a reposition transition. And because we're changing and moving margins around and size and top left alignments, we got these subtle animations for free. So in Portrait, we decided let's put all the number boards on the bottom, and we just moved those number pads across to the bottom and centered the game board back. And so as we go back to landscape view, you can see that now they're back to that view. But all the time, everything is still in effect here. Still got the app bar and all that good stuff. So that was an approach that we used for Sudoku, using the VSM approach that worked very well for us, and arguably it's a very simplified casual game. But it is an easy approach, and we're interested to get your feedback on using VSM for layout management. So just a recap of kind of what we just showed here. This is the VSM approach, defining the visual states. Again, using what the API is going to provide you so that you can, as the names for the visual states, so that you can use a helper method like this to basically say, hey, I just want to go to state and give me what state that I've been in here. Now, the last thing I want to talk about is pixel density. So we've talked about screen sizes, we've talked about orientation, and the last is pixel density, right? So I have my baseline resolution, my tablet, which has a certain DPI and size, but I may have that same physical form factor, but on a different screen resolution. And you can see here on the example here of using the Tweetorama app that on the higher resolution, what the challenge is that as the pixel density increases, the touch points might not be ideal, and they get too small to touch. In this case, the text box. So what Windows does is we scale the application, and we scale it so that the targets are maintained and the application, kind of the aspect of the application, is maintained. And that gives you both good touch targets as well as crisper things that are on the screen. So there's 3 scale percentages that you can adapt to in your application. So there's what we call 100%, 140%, and 180%. And here's examples of what they are at the DPI. These are kind of the minimum DPI levels of those. The scale factors are actually in ranges. So it's, I guess you could read this as 148 DPI to 207 DPI is the 100% range. And then the next range is the jump up. So it's not that literal DPI. It's anything that falls within that range. So how do you do this in XAML, or what do you do in XAML? Now, mostly this applies if you're following the flow layout or fluid layout approach of star sizing and stretches and things like that. As we scale the application, a lot of that should just work for you. However, there's certain areas that you want to make sure that you adapt to, perhaps images, and you want to provide crisper images or assets. XAML is a vector-based environment, so we would say when you can, avoid using bitmaps in certain scenarios when scaling will happen, and use vectors when you can. John, in his session, talked about 9-grid. So there is an ability for you to perhaps use the 9-grid attribute on some images if it makes sense. Of course, if I put 9-grid property on a profile picture of a person, that probably doesn't make sense. Something will stretch in the middle, even though it's already stretching in the middle. But that wouldn't be appropriate there. The second point is what you would do is if you have bitmap assets, you would provide them for each of those different scale factors, and I'll show you in a second what those are. And so knowing these things in advance will help you develop your application to adapt to these things. The third thing you can do, which is probably the most extreme and I would say not a mainstream scenario, is you can actually listen for those DPI notifications yourself. On that display properties API that we used for orientation, we also get PPI notifications or pixel per inch notifications. So we will know, and we can get the arguments of what the values are. I would say, again, that's not a mainstream scenario. So I mentioned about how you would structure your application at the source. Let's use this example where I have a bitmap-based asset, in this case, perhaps a picture of my product. Now, this is XAML. This is an image element, and I'm saying, hey, show width 100 and 100, and the source is this image called product PNG. Now, in my source project, you can see that I actually don't have an image called product PNG. I have these images called product.scale dash and a number. So this is there's actually a talk tomorrow, and it's on the related slides here from Kip Knox, who owns the API that is doing a lot of this for us. And we in the XAML team, in our application model, are actually using those APIs to work on behalf of you, the developer. So you can set this images assets product PNG, and we do the work to integrate with the resource manager and say, what's the scale factor, what DPI am I at, et cetera, et cetera. What do I need to do? What is actually the asset that I really need to show here, given the best circumstances and the context that I am aware of? So if I'm at 100 scale, if I'm on the baseline resolution, then what would be returned to that image element is that product scale 100 image. If I was at higher DPI levels, you wouldn't have to change your XAML, and the API, the runtime in the application model would know, actually, I need this image because I'm at a higher DPI. This is a very simple example using images. The same mechanism is actually used for localization and other aspects and resources as well that I'm more than happy to talk with you about. And actually, there's a localization talk tomorrow afternoon. So just to recap, the key points that we want you to understand is understand adaptability from the beginning. You're hearing a lot about user experience, probably one of the first times that Windows themselves are really reaching out to independent developers and making sure that user experience is first in your minds. And so understanding adaptability from the start. You will have a snapped view. You're not going to be in control of when that happens. Users will be able to rotate your applications. Screen sizes are different. Windows allows users to be in control of what machines they use. So understanding all of that and knowing that from the very, very beginning, and adapt your application and your development and start your project from the start. That's the key message. The second point is that from a XAML-specific thing, don't listen for resize events for specific orientation and layout changes. We're surfacing those for you in the API in WinRT, so that you can be very specific of when those events distinctly have happened versus resize, which can happen perhaps more frequently depending on what other things are going on in your elements. Use the VSM, the Visual State Manager pattern, or the navigation framework to help you manage your views and landscape, as well as your snap view if you want to provide a unique experience in your snap view. And then for pixel density, when possible, favor vector over bitmap for just kind of free scaling that you'll get out of the box. And so when you do this, of course, your users will be delighted. Your ratings in the App Store will be high. You'll make more money, right? So that's the goal for you as a developer. These are some of the related sessions. There's an HTML counterpart to the session that shows the HTML techniques that are basically similar to VSM and things like that. The one session that talks about the other MRT type stuff is by Kip Knox. I thought it was listed on here, but it's not. But if you're interested, I can point you to it. And then there's other sessions about locations and sensors specifically, so if you want to know how the orientation and the gyroscope and things like that happen. SDK samples for a lot of these things are available at the Windows Developer Center, so if you haven't visited that yet, it's like 160 or so samples about all the different APIs. Both the layout management, the display changes, orientation, PPI, all that stuff have further SDK samples that are micro-specific scenarios at dev.windows.com. So thank you very much for coming. Please remember to give us feedback both for this session as well as we're starting to lurk on the forum. So if you have questions there, please give us feedback. And I know it's lunch, so I'll be able to stand on stage and answer any questions for you at this time. But thank you very much for coming. Enjoy the rest of the week.